Okay, so in this video, what we'll see is, we'll see a new program. We will see a new program. So write down the question. The question is, write a program in Java to find the maximum element of an array. I'll repeat, write a program in Java to find the maximum element of an array. Okay. Now, what I'll assume is the initial part. If you saw my previous video, right? In the previous video, we had to first find the sum of elements of an array. Now, in that video, what did we do initially? We initially accepted input from the user. You had to start from import java.util.start, then you wrote the class array, then the main statement, public static void main, and then inside that function, you first defined the scanner object, then you accepted the size from the user, then you accepted the elements from the user and you stored them in the array. And after that, what did you do? You moved on to the actual part where you had to find the sum of the elements. And then we moved on to the part where we had to find the product of the elements. Now that initial portion of accepting the size, accepting the input, that portion for this program also remains the same. Okay, that portion remains the same. The only thing that will differ is the portion where we have to find the maximum element. Okay, so I'm not writing that portion, I'm not writing the initial part. I'm going to start from the portion where I have to find the maximum element. Okay, I hope this is clear. Now, in order to find the maximum element, there are a few steps. The first step is I have to assume that the first element of my array is the maximum. I'll have to assume that the first element of my array is the maximum element. What is the first element of the array? The first element of the array is the element which is at 0th index. And how do I access the element at 0th index? I access the element at 0th index using the name of the array and within box bracket writing 0. So this will give me the first element and I'll store the first element in max. So what am I doing through this step? Through this step, I'm assuming that the first element of my array is the maximum element. I'm assuming that, okay? Now, after this assumption, what will I do? I will now start from the next element, which will be the next element, the element at position 1. So I'll be starting from the element at position 1 and I'll be checking whether I can find any element in the array which is greater than max. If I find an element which is greater than my assumed maximum, then I'll change my maximum to that element. So let's see how we can do that. So I'll run a loop. So the next element, I've already assumed the 0th element to be my max. I'll start from position 1, the next position. And I'll go up to, I'll use the length attribute. So I'll say arr.length. You can also use the size, it's up to you. So I'll say I is less than arr.length. And then I'll do plus plus I. Okay, fine. Now, see. Now what I can do is, now I'll check. What will I check? I'll check what is my current element. My current element will be my ith element. So I'll check if my ith element, is greater than my maximum or not. If my ith element happens to be greater than my maximum, then I'll update my maximum. I'll update my maximum element to the ith element. And I'll also keep track of the position. So I'll have a variable called position. So initially the maximum element is the 0th element. So initially the position is 0. So if the max is changed to the ith element, my position will also change to I. Okay. Now after the position is changed to I, what will I do? I'll end my loop. So I'll keep on doing this for all the elements of the array. And after I'm done finding the maximum, I'll simply print out a statement. So I'll say system.out.print maximum element is plus max found at position position. Okay. So this is how, so this will be the end of the main and this will be the end of the class. Now let's do a dry run. We'll not stop here. We'll do a dry run. Let's say I have an array. Let's say I have an array. The name of the array is ARR and it contains 4 elements. Let's say the elements are 12, 9, 16 and 4. And the indices are 0, 1, 2 and 3. Okay, so let's do a dry run. So let's go line by line. Let's go step by step, statement by statement. So the first statement is max equal to ARR of 0. So max will be ARR of 0. What is ARR of 0? ARR of 0 is 12. Okay, what is position? Position is equal to, position is initially equal to 0. So position is initially equal to 0. Now you start the loop. What is the value of I? The value of I is 1. What is ARR dot length? ARR dot length represents the number of elements in the array. How many elements are there in the array? 4 elements. So ARR dot length is 4. So obviously 1 is less than 4. Condition is satisfied. You come inside. Now what about ARR of I? ARR of I means this element, right? Is it greater than my max? Is 9 greater than 12? No. So this condition is not satisfied. These two statements will not be executed. You will go to the updation part. Now I will change from 1. I will change from 1 to 2. I changes to 2. Now again you check the condition. Is the condition satisfied? Yes, the condition is satisfied because 2 is less than 4. So you come inside. ARR of I. What is ARR of I? ARR of I is ARR of 2. What is ARR of 2? ARR of 2 is 16. Is 16 greater than max? Yes, 16 is greater than max. So you come inside. So max will become ARR of I. What is ARR of I? ARR of 2. So ARR of 2, which is 16, that will be now stored inside max. And position will be I. What is the value of I? The value of I is 2. So position becomes 2. That means position will give me the position of the maximum element inside my array. Okay. Now next again you go back up. I becomes 3. Then you check the condition is satisfied. So you come inside. Now you check ARR of I. What is ARR of I? ARR of I is currently 4. See, ARR of I means ARR of 3. The value of I is 3. So this element, is it greater than my max? Max is 16. Is 4 greater than max? No. So this condition is not satisfied. You will not be executing these two statements. Again you go back up. I becomes 4. Is 4 less than 4? No. Condition is not satisfied. So your loop terminates. You come out and you print maximum element is 16 found at position 2, which is indeed correct. If you look at this array, the highest element is 16. Okay, so this is how you would find the maximum element in an array. Okay, now let's take up the next question. Write down the next question. Write a program in Java to find the minimum element of an array. I'll repeat the question. Write a program in Java to find the minimum element of an array. So how would you find the minimum element? See, it's very simple. You only need to make one change. You need to make a few changes rather to this. So I'll be making the changes. You have to write the entire program, okay? You'll have to write the entire program. So I'll assume the first element to be my minimum. And next, what I'll do is let the array remain the same for me to do the dry run. Now I'll check if the current element happens to be less than my minimum, then I'll update my minimum. I'll update my minimum to the ith element. And then here I'll print minimum element. I'll print minimum element is, what is it? It's min. Minimum element is min found at position this. Okay, now let's do a dry run again. So instead of max I have min. Now let's see how things work. Okay, so this is 9 and this is 4. Let's see if I can get the minimum element. So I'll start from this part. Min is equal to ARR of 0. What is ARR of 0? ARR of 0 is 12. So min is 12. Now what is position? Position is initially 0. The position of the minimum element. Now you start from I. I is equal to 1. Is I less than ARR dot length? Yes. ARR dot length is 4. 1 is less than 4. You come inside. ARR of I. What is ARR of I? ARR of I is, what is the value of I? The value of I is 1. So ARR of I means ARR of 1. So this is 9. Is 9 less than 12? Yes. This condition is satisfied. So you come inside. you update your minimum. Min is equal to ARR of I. So min becomes ARR of I, that means min becomes 9. Now you check. Now, and of course you need to assign the position as well. Position is equal to I. So position becomes 1. Now again you go back up. Plus I. So I becomes 2. Now you check. Is I less than ARR dot length? Yes. So you come inside. If ARR of I means ARR of 2. ARR of 2. Is it less than min? Is 16 less than min? No. Condition is not satisfied. So these two statements will not be executed. Again you go back up. Plus I. So I becomes 3. I becomes 3. Now you check. Yes, 3 is less than 4. You come inside. ARR of I. ARR of 3. ARR of 3 is this element, 4. Is 4 less than min? Yes. Min is 9. 4 is less than 9. You come inside. Min equal to ARR of I. So min becomes ARR of I. ARR of I means ARR of 3 because the value of I is 3. So min becomes 4 and position is equal to I. So position is equal to 3. Now the value of I becomes how much? The value of I becomes 4. Now 4 is no longer less than 4. So you come out and you print minimum element is 4 found at position 3, which is indeed correct. Out of these 4 elements, 4 is the minimum element and it is found at position 3 at index 3. So I hope this helps. You can leave your doubts in the comment section below. Thank you.